Let's have a look at the quiz. So here we go. Number one, if a wood block slides down an incline at a constant velocity, the force of friction must be equal to, if a wood block slides down an incline at a constant velocity, right? We got FD. If it's sliding at a constant velocity, the force of friction must be equal to FD, right? That's B, FD. So you guys check to see if you get that one right or not. And if you didn't, I would recommend that you jot in the right answer on the sheet. Got it right, Blake? All right. This one here, I already sort of went through. A box of weight W rests on a plane at incline at 30 degrees. What is the magnitude of the component of the weight that acts parallel to the incline? In other words, how much is FD? FD is mg sine theta, but m times g, we're told, is equal to W. So it's simply sine 30 degrees. Sine of 30 is half, so 0.5 W. No, the m times g is the W. The weight is W. The weight is W. The weight is W. It's all right.
Can you explain that again?
Sure. We've got W straight down, right? FD is equal to mg sine theta, but our mg is our weight force, which is equal to W. Our W is our mg. The weight is mg, so it's W times the sine of 30, which is 0.5 W. Okay. An empty wooden crate is slid across a warehouse floor. If the crate were filled, the coefficient of kinetic friction between the crate and floor would, if you put more stuff in the crate, what happens to the coefficient of kinetic friction? Nothing. It stays the same. Right? Because the coefficient of friction is only dependent upon the surfaces. So it stays the same. Now, I believe the next question says, an empty wooden crate is slid across a warehouse floor. If the crate were filled, the force of kinetic friction would? That would increase. Why does that increase? Well, because mu equals F over Fn. If the mu has to stay the same and the thing is filled, that means that the normal force gets bigger. So for mu to remain the same, what has to happen to friction? It also has to get bigger. Exactly the same amount, right? If you put 10 times, if the crate now weighs 10 times as much, guess what? The force of friction is going to be 10 times as much. Correct answer is B. How we do? Not bad. Oh yeah? A 5 Newton block with a surface area A is dragged across a horizontal wooden table and experiences a friction force of 2 newtons. What is the friction force acting on the 5 Newton block when the surface area is increased to 2A? Jory, what's the correct answer? B, exactly the same. The surface area does not change the friction force. It's only the nature of the materials and the size of it, right? The mass. How do we do there? Which pair of quantities could be used to determine the coefficient of friction for granite on concrete? The mass and speed of a block, mass and normal force in the block, frictional force and speed of the block, frictional force and normal force in the block? Yeah, D. Friction and normal force. Friction and normal force. How'd we do? I think we did okay. I saw that up there before. Yeah, not bad. The force required to start an object sliding across a uniform horizontal surface is larger than the force required to keep the object sliding at a constant velocity. These forces are different because the force of friction is less than the force of static friction, right? Force of kinetic friction. Force required to start an object sliding across is larger than the force required to keep it moving. How come? Because kinetic friction is less than static friction. D. Didn't do so well there. This one, also not so good. A 50 Newton horizontal force, I guess, I'm missing the word there, is needed to keep an object weighing 500 newtons moving at a constant velocity of 2 meters per second across the horizontal surface. The magnitude of the frictional force acting on the object is, if it's going at a constant velocity, it's exactly the same. 50, right? Net force, 50. 50. We should have done better there, you guys. What did some people want to say? Hey, they said 500. It's not equal to the weight. And certainly not a subtraction question. Make sense? Yeah? A 20 Newton block slides over a horizontal table. If it takes a force of 5 newtons to move the block at a constant velocity, what is the force? Isn't that the same question?
Yeah.
But yet we did way much better on this one. 5 newtons, right? 5 newtons. A 20 Newton block slide. Oh. Here we're asked for the coefficient of kinetic friction. Okay, well, I'm going to draw a little picture here. 20 Newton block, that's my normal force. And it takes 5 newtons of force, right? I shouldn't do it like that, but that means that friction then is also equal to 5, right? So my mu value is friction over normal, 5 over 20.25. B. How do we do? Oh, not so good. How would you get, some people said A, how did you get 0.1? How do you get 0.1 out of those numbers? Magic. It's not subtract, it's not multiply. I don't know how you get that. Some people just guessed, didn't you? Clay, did you guess? Yeah. Okay. Oh, that's it. Okay, so might be a good idea to go over those, just make sure that you've got in your own mind how those things work. I would like at the end of this period, I would like, there's the 2 handed assignments. Unfortunately, there are 2 separate sheets of paper. There's the flat one, which is an A and a B, and there's the one that I handed out just at the tail end of yesterday, which is the ramp one, right?
8 of them. Why are you missing one?
Pardon me? I don't recall, yes.
Yeah, I don't know.
I don't know. But there's extras over there. You got this period to work on those. You got this period to work on problems. Mr. Smigalski's going to take over tomorrow. He's going to talk about static forces, forces that make the net force equal to 0. And we will be looking at a test in the very near future. I'm thinking 2 days, Mr. Smigalski, for the static stuff.
Sure.
2 days, 2.5, something like that. So you're probably looking at a test probably about Tuesday, if I give you a date for review kind of thing. So Tuesday. Plan on Tuesday.